Welcome everyone, and in this video I'm going to talk about the d orbital's shape. Now, as I said initially, that the d orbitals has electron capacity of 10, meaning d orbitals can accommodate 10 electrons. That's the maximum number. So if I decided to draw it, I can decide to sketch something like this. So I will have a situation whereby electrons will pair. So what do we know here? The electrons pair, but before they pair, each orbital is singly filled based on Hund's rule. Now, the key thing that I'm going to talk about in this video are the shapes. So the key thing that you have to know here, that electrons are found in the space between these orbitals. They are found in the space. So if that's the case, d orbitals are just improvements of the p orbitals. So to know the shapes, the key thing that you have to know, initially we said that p orbitals, sorry, let me use a different color so that you can see. The p orbitals had x, y, and z. Even the d orbitals follow this principle. But the key thing that we have to know is that the first shell, the first orbital, sorry, takes the x and y. And therefore, we are going to call it the dxy. So we call it the dxy. The second orbital takes from this same combination, it takes the Y and Z. And therefore, we are going to call it the D, Y, Z. The third orbital, X, the X and Z. It takes the X and Z. And therefore, we are going to call it the D, X, Z. The fourth orbital, because we're supposed to have 5 of them, the fourth orbital takes the X squared, Y squared minus Y squared. And therefore, that orbital will be called the D, X squared minus Y squared. The lastly, which is the fifth orbital, takes the Z squared. And therefore, we call it the D, Z squared. Now, having known that, how can we understand the shape? How can we understand the shape? Now, to understand the shape of the D orbital, you need to understand the system of 3 axes. So, the system of 3 axes works this way. I'm going to draw it. Just a sketch. Now, the axes are, we have the X axis, the Y axis, and the Z axis. So since we are having the 5 orbitals, they are supposed to be found in the spaces of the axis, because all these axes are right angled. They are right angled, meaning they are perpendicular. They are perpendicular. So that's what is going to help us understand the shapes and how spaces within which we can find these different types of orbitals found in the D. So first thing, we need to know that The axes are orthogonal. This one to mean they are perpendicular. Next, to draw the axis or to draw the shapes, we need to pick two axes at a time. Meaning, if I want to draw the shape and the spaces within which certain orbitals are found, I cannot pick the three axes at a time. I only pick two. So I can take, for example, I can have the axis between x axis and y, or I can take the axis of y and z, or I take the axis of x and z. Meaning I cannot use all the axes at a time. It will make understanding the shapes of the d orbital more ambiguous. So you really need to know what you are dealing with at a time. So, for example, if I want to draw the shape of the first orbital, I want to draw the shape of first d orbital. And we said the first d orbital takes, it takes y, x, and y, and therefore we are going to call it the d x y. So meaning the axis I'm going to use is only the x and y axis. So when drawing, I simply come and draw x and y axis. So I'm going to draw it that way and that way. So it must be x, this side is y. So I'm supposed to have my orbitals being found between the spaces of x and y. So I'll draw my first dumbbell here, next one here, next one here, and the other one here. So what does this one show? So from the drawing, we can say that the d orbital, the dxy orbital, is found between x and y axis. Is found between x and y axis. Next, shape the second d orbital. Shape of the second d orbital. And the second d orbital, we said, is taking y and z axis. It's taking y and z axis. When that happens, so we are going to call it the d, y, z. So it means that I'm only going to use the y and z axis. So that's what I'm going to draw. So down here, I'm going to have a drawing like that and that. So it is going to be a z and a y. And that's where I'm going to put my orbitals between the spaces. So the first dumbbell is going to be here, that space. The next one is going to be here, between the spaces. What does that one show? That the d, y, z is found between the y and z axis. Good. Shape of the third d orbital. Shape of the third d orbital. And we said initially that the third d orbital takes the x and z axis, and we are going to call it dx z. That's what I'm going to sketch. That's what I'm going to sketch very well. Going to be x, and this one is going to be z. And I'm going to put my orbitals between those spaces. So what does this one tell us? It tells us that the dxz orbital is found between x and z axis. I'm going to the fourth orbital. Shape of the fourth d orbital. So we said initially that the fourth one takes the x squared y squared. It is going to be x squared y squared planes and axes. So we are going to call it dx squared minus y squared. So when I want to sketch, I'm simply going to use the x and y axis This one is X. This one is Y. But now what you have to know, the dx squared y squared is not found within this space. So because it is a plane, when drawing it in 2D, it may appear to be occupying that given space. So this is how we are going to sketch it. It's going to be within that line, within that line, within that line, within that line. But the key thing is it tells us that the x squared minus y squared is drawn along the x and y axis. So it overlaps on those spaces, but its center is within the lines. Lastly, the shape of the fifth d orbital. Shape of, sorry, it should be fifth. Of fifth d orbital. So we said initially that the fifth d orbital takes z squared takes the z squared. So most of the time whenever you are drawing this shape, we are interested in the z squared, and we are going to call it d z squared. I want to show you how that is drawn. Even though I'm doing it in 2D, if you can get a 3D, can be better. I'm going to draw the first line. So this is y over x. Then this is z. So when sketching it, there's a small overlap at this point. There's a small overlap at that point, but a bigger one is running along the z axis. So it shows that the dxz squared majorly dominates the z axis. It majorly dominates the z axis. Thank you very much. That's what I had as far as shapes of the d orbitals are concerned. Have a wonderful time.